hospitalization notified by individuals' socioeconomic status in a subtropical metropolis. It is a seasonal time series studies in Hong Kong with 20 years data. Okay, I will start with some backgrounds. As we know, climate change has been one of the most challenging public health issues in these centuries. And compared to the pre-industrial level, the planet is like a 1.1 degrees Celsius warmer, and the warming trend is projected to continue in the future, mainly driven by the anthropogenic emissions. It's been widely evidenced that high ambient temperatures and heat waves contribute to increased mortality and morbidity worldwide, particularly affecting cardiopulmonary diseases, infectious diseases, and mental illnesses. It's also observed that daily minimum temperature increase faster than the maximum temperatures, especially in high latitude regions. And so the trend of nighttime warming has gained increasing scientific research, given its potential impact on human health as well as the whole ecosystem. And then, how can hot nights be a threat to human health? This is because it will interrupt rest and sleep. Physiologically, your core body temperature is supposed to decrease when you start falling asleep. But the high ambient temperature at this time will prevent this process, leading to various negative health outcomes, such as impaired immune and metabolic functions, reduced cognition and cognitive performance, and increased susceptibility to chronic diseases. And for city dwellers, hot nights could be more impactful and just why? Because the urban heat island effects make cities hotter than the rural areas, and it also makes the nighttime heat distribution vary dramatically between the cities. That those densely populated regions are often hotter at night, and these regions are also home to many deprived communities and individuals who have limited options to cope with excessive nighttime heat. So people concerned more frequent and intensive hot nights can exacerbate the existing inequalities in the cities. Here is a plot showing the frequency of hot nights in Hong Kong. We see the red spots refers to higher frequency of hot nights, and they are mostly concentrated along the shores. And this area is also known to house many lower class individuals. So here are some findings from the lately hotline studies. For example, a study in Eastern Asian countries shows that mortality rates could be like up to 50% higher on hotline days compared to non-hotline days. And another study in Southern Europe shows the risk increased by 12 to 37%, and the hazard for respiratory and cardiovascular diseases are even higher. And a study in Hong Kong showed increased mortality rates due to hot nights, especially coming from 5 or more consecutive hot nights. So however, some research gaps exist. First, this hot night study primarily examined mortality impact. No study has investigated the hospitalization risk due to hot nights. And second, individuals in low socioeconomic status could be more vulnerable to hot nights. However, most temperature health studies examine risk in different age and gender groups, but few has looked at size group difference currently because they lack of effective sex indicator. So our study mainly tries to address these 2 points. So given the assumption that the intensity of nighttime heat plays a role in inducing hospitalization risk, and low sex individuals are more vulnerable with exposure to excessive nighttime heat and hot nights, we conducted the seasonal time series analysis to examine short-term association between non-cancer, non-external hospitalizations and hot night metrics among overall and age sex-specific populations. For information, a hot night is officially defined as daily minimum temperature greater or equals to 28 degrees Celsius per the HKO observatory. We use data from 2019, 20 years, mainly May to October 6 months because hot nights were only observed in these months. And then we collected daily counts of NCN hospitalization, which are further stratified by individual levels, individual status to levels high and low. and I will give more details later. And age, the three levels as listed here, they correspond to the children, the working age, and the elderly. And we also collect weather data, which are daily and hourly temperature, daily relative humidity, daily rainfall, collected from a fixed weather station located in the middle of Hong Kong. And we add the air pollutant data in the sensitive analysis. Now, what indicator we use for individual SASS? Individual SASS was determined by whether patient were receiving public assistance, short for PA, namely financial support from the government to cover their medical expenses at the time of admission, and eligible recipients of PA were individuals with limited income and assets, including recipients of certain social welfare schemes and those belonging to vulnerable groups such as low-income individuals, chronically ill patients, and elderly patients living in poverty. Their eligibility was reviewed and determined by designated social workers, and that's why we think it's a reliable indicator for individual level SASS. And for clarity, risk PA refers to low SASS and no PA refers to high SASS in this study. And then we created two hotline metrics. The one aligns with the official definition of hotline in Hong Kong, which is the hotline date defined using a daily minimum temperature of 28 degrees Celsius as a cutoff, short for HMD 28. And the SEC is a binary indicator, value 1 for hotline days and value 0 for non-hotline days. And the second one is numeric variable. It's called hotline excess to represent the intensity of nighttime heat. So first we define nighttime from the 6 p.m. of the previous day to 6 a.m. of the current day, in total 12 night hours. And then we calculate the sum of extra degrees of the hour temperature above the 28 degrees Celsius during the night hours. What does it mean? It means we first calculate the difference between the hour temperature and the 28 thresholds, and if the difference is greater, is positive, then we keep it. If it is negative, we force it to 0, and then we sum up by day to get the daily HME series. And then we fit the focus on generalized identity model with a variant of difference approach and distributed like nonlinear models for the overall and the age size specific hospitalizations. The DID method is used to adjust for the temporal components in the outcome series like transitionality and autocorrelation. Technically, the ID method provides causal and emotional estimates for the association of interest plus relative flexibility in controlling for those time components I just mentioned about. And DRMM methods is used to allow for nonlinear and delay effects of the target exposure, namely the Hamann metrics. And we allow for a maximum lag day of 5 days because the heat effects are so short. And then we apply a W variant penalty on the lag dimension, given the assumption that the effects will get smoother along the lag and approaching now along the lags. Here shows the equations for the full model. IP and IT refers to the dummy variables for panels and bay within the panels, and CB refers to cross basis function created using DLM, and HN refers to hotline, and daily mean temperature will control for to represent the average heat effect in a day, and also control for relative humidity and rain and holiday effects and day of the week. And here I show some preliminary results. The table is for the summary statistics. So during the whole 3680 study days, we collected 5 million hospitalizations, and 57% of the study day experienced excess nighttime heat that is HME greater than 0, and the HME is ranging from this minimal values to 55 degrees Celsius with a median of 8.1 degrees Celsius. And we identified 499 HMD 28, which has mixed HMD ranging from 1.9 to 44. And so we can see some day with extreme HMD, namely greater than the 45 degrees Celsius, were not considered as hot nights, given the official definition of hot nights in Hong Kong. And the top two plots shows the time frame. We can see the occurrence of HMD 28 and HMD greater than 0 days increase obviously during the past 2 decades, especially from the 2014 onwards. And the bottom two plot shows the seasonal distribution. We can see the HND 28 and HND greater than 0 days occur earlier and throughout the summer months in recent decade, the red part compared to the former decade, the blue part. So it's the main results. The table shows the cumulative excess risk of hospitalization associated with 100 days and HND in Hong Kong. For information, the figures in bold refers to statistical significance. The rows refers to subgroups cross-stratified by age and size, and 2 to 3 columns are for the HND models, and the left 3 columns are for HND models. So from the third column, we can see no significant hospitalization impact was reported for HNV 28, but from the right columns we can see low sex individuals were widely affected by rising HNV, while high sex individuals appear to be not sensitive to HNV. And for the low sex, we can see extremation increased hospitalization risk by nearly 12% for children, 6% for working age, and 7% for the elderly. We think that the HNV is indicated hospitalization habits in Hong Kong. Okay, to summarize, we find the intensity of nighttime heat plays a significant role in increasing hospitalization hazards. So we suggest this metric can be considered into developing a HANA definition that has important implication on health. And second, there are distinct socioeconomic disparities in the hospitalization risk due to excessive nighttime heat. And those socioeconomic disadvantaged individuals, regardless of their age, are particularly and widely affected. And we suggest the mitigation action should be tailored to protect this subpopulation. Some limitations should be noted. We use ambient temperature from a fixed weather station, so the personal. Okay, thanks. That's all this reference, and thank you for your time. All questions are welcome.
We have 1 minute for quick question. Any question?
So thank you for your presentation. I have a very simple question. That in your research, did you consider the disease-specific hospitalization? Disease-specific, like a cardiovascular disease or respiratory disease. So maybe the pattern could be different when you consider the type of disease.
Yeah, actually, we have those data, and we anticipate the cardiovascular and respiratory risk to be higher due to hot nights. But unfortunately, when stratified by the individual SATS indicator, we found the sample size would be not that sufficient, so we didn't do that part.
Yeah, thank you.
Thank you for your presentation. Thank you.